Hi, welcome again to the Ivory Tower Collections. I wanted to show you another item that I have, piece of test equipment I use, that I purchased, I guess, a couple of months ago. And the cool thing about this is, similar to my old BK Precision oscilloscope, this piece of test equipment is older than I am, but no less, actually probably more useful than I am too. But anyway, what you are looking at here is an old California Instruments digital multimeter and counter. Basically, this is a bench multimeter for testing voltages and resistance values, as well as a frequency counter. And I don't know the whole history about this thing. I really can't find much about it on the internet. But the reason why I grabbed it, besides having a really cool bench multimeter and a signal counter, which I didn't have a signal counter before, is one other thing, which will be quite obvious once I power this on. But for starters, again, it's made by California Instruments. Near as I can tell, the IC chips that are inside of it, the latest date stamp I can find is from 1971. So it is rather vintage. Additionally, it was obviously quite heavily used. It's got some scars on it and some battle scars, as it were. And it was originally part of, it was some test equipment for Pacific Southwest Airlines. It's got a serial number, like an asset tag serial number here. And it also has a big PSA logo on the very back of this thing. I'm not sure exactly if California Instruments made these specific or if it was like a kit. It's very heavy. This is like a solid steel construction box with an acrylic smoked front plexi on it. But yeah, it can check resistance here in K ohms. In fact, these are my mode selection buttons here. I've got my resistance, DC voltage, AC voltage, and then this is the signal counter here, frequency counter and kilohertz. And then over here is my range selector, so it's not automatic. I have to basically choose where I want my decimal place to be to get an idea of the accuracy or whatever it is that I need to measure. And these white lines up here dictate which of these range buttons are valid to use depending on which mode. So for instance, with resistance, it's measured in K ohms, kilo ohms, but I have my decimal place of my ones, tens, hundreds, thousands, and 10,000 right here. DC voltage and AC both can only choose between 1, 10, 100, and thousandths place. And then the frequency counter, it can go between the 10 to 10 thousandths place. So that's it. So what I'm going to do is I'm just going to fire this thing up, show you a couple things that I'm going to check on it so you can get an idea as to how fairly accurate this thing still is, even this many years later. And yeah, give you a quick intro to my wonderful little California Instruments digital multimeter. Okay, and I'm back. So here we are. We're a little more zoomed in on the multimeter here. And I'm going to go ahead and turn it on real quick, and you'll be able to figure out pretty quickly why I grabbed this little guy when I did. Actually, he's not little at all, he's quite large. And what's fairly unique about it. So I'm going to hit the power button right here. And there you go. I don't know if you can see it or not, or if you can tell. I will zoom in on the display a little bit more here. And see if we can get the camera to, there we go, focus in on it. Stabilizer's kind of fighting me a little bit. Yes, I don't know if you can tell, but it uses Nixie tubes for its display readout. Right now I've got it in DC measurement mode, so that's why there's a plus sign over there, but obviously the plus sign goes away if there's a negative voltage reading. So yeah, it's pretty neat. I've got a couple of resistors here on top I thought I would plug up to it real quick so we can just kind of see what the readings are and see how accurate it and maybe the resistors are. So let me get some test leads here. And the first one I will start off with will be a 68 ohm resistor. So since this is measuring in k ohms, oh wait, actually we're in DC. Let me switch over to the resistance here to ohms. And obviously it's got a really large number on it right now. Sometimes it does this and I just have to push different buttons or sometimes connect up the leads to zero it out real quick, like that. Oh well. It gives me a crazy number here, but it should still read fairly accurate. So let me attach this 68 ohm resistor. And there we go. And according to this, it's reading at about 67. And if I go to the tens position there, then it reads at right at 68 ohms. So in case you can't tell, this position here would be the 1 k ohm position if that's what it was registering. And I will zoom in a little bit more on that display so we can get a better reading on it. There we go. Okay. So yeah, that's a 68. Let's see, what do we got over here? We've got a 47 k ohm. So I'll just get that attached up here real quick and don't have it re-attached here. There we go. Get that side on. And there we go. Since this one's actually, oh, I'm sorry, yeah, it's 47 k ohms. My mistake. Yeah, so I had to change the reading position there. So according to this, it's at 46.73. And obviously you've noticed that it rounds up automatically as I change the measurement. So now in the thousandth scale here, where I can actually read 1 k ohm or hundreds, I'm getting 46.8. And if I go to here, it'll probably go straight to 47. So it just rounds right up there. Again, 46.8. And the more closer accurate reading is this one here, which is 46.73. If I go to the 10 spot, it's out of range at that point. So it just kind of throws these error conditions. There we go. Okay, so that's a 47 k ohm. And then let's see, I've got another one here. I'm not sure if this is the right value. It says it's a 2.2 k ohm as well. So let me test that real quick. Yeah, 2.15, 2.2. So that seems to be pretty much where it needs to be. And then I've got this whole stack of them here. So yeah, so that's pretty cool. So that's the ohms or resistance check measurements. So I'm going to switch off here, change these leads around and set the variables up a little bit, and we'll check some voltages. Okay, now I'm back and I've got a couple of 9-volt batteries up here, as well as a Atari 5200 power supply that I thought we could check with the DC measurements here. So we'll start with the batteries first. And again, these are fairly old. You can tell by this old Energizer I've got sitting here. It's a fairly old 9-volt battery that I've had laying around. So when checking DC voltages, if you want an accurate reading, it is important to make sure that you get your polarity matched up right. So let's see here. This is registering about 8.462 volts. And again, if I drop it down, it might start to round up. So just looks like it's staying at 8.4. Yep, 8.461 thereabouts. And what would happen if I reverse the leads? Well, instead of that plus sign being a plus sign, it should switch to a negative. So we'll get the same reading, only now it shows a negative instead of a positive. Okay, so that's roughly just under 8.5. Here's a newer-ish Duracell. Now you can see I've already written the voltage reading on it right here, where I put 8.13. Now I probably measured that with my fluke, and I know that's accurate. So let's see, we can check this and see what reading we get with this multimeter. And it says 8.152. And let's see, 8.14, 8.15. So yeah, according to this, it's roughly at about 8.15. So let's see if that's accurate. We'll leave that there for a second. I'm going to get in front of the camera here for a second to grab my fluke. And we are on a DC measurement volt. Let me scoot this back a little bit so I can set this up here, turn the backlight on. I'm not sure, yeah, it's not going to show up there, is it? Okay, so I have to think of another idea here. I'll just have to set it on its side. We'll just have to work with that. Okay, so same test. We're going to use my probes here, off my fluke. I'm just going to have to hold them in place here while I try to get this. So again, I had 8.13 written on the battery. We're getting 8.14, almost 8.15 on the old multimeter. And the fluke says 8.14. So yeah, looks like they're roughly in agreement. So nice. So again, I'm sure that with age, I'm sure this thing's drifted quite a bit, this old multimeter, but for the kind of stuff I do, it's going to be more than accurate. Besides, it's really cool. And I like the large readout of the Nixie tubes that are on it. So that's checking a couple of batteries. But what about the other voltage readings, AC and such? Well, I don't have any good probes to really test for AC voltage with this. Now technically I could attach it off of like maybe an audio wire or an audio line and maybe check what little bit of AC voltage might be coming off of that. So maybe I'll try and give that a shot. Okay, I'm back. This won't be the best test, but just to kind of give you an idea of kind of an AC reading, I have the probes connected up to the audio output on my Sega Genesis. And so what I'll do is audio output on the Sega Genesis, if I didn't say that before, is I will start some music here, and we will see the voltage reading here change periodically with the music. It'll be kind of slow. This isn't a very fast multimeter. In fact, I've really noticed on the frequency counting side, which I'll show you in a little bit, that it can be pretty slow. So let me just start up a song here. And you can see that the voltage fluctuates, and it really depends on the amount of current or amplitude or volume, or basically just how much stuff is being sent out. In this particular case, we're only checking just one channel because again, it is a stereo source. So get the idea there. So I'll stop that song for now, and we'll start up a different one. Let's see, how about this one? So, yeah. And let's see, here's one that has quite a bit to it, courtesy of J-Red Astro Blaster. Yeah, so that's checking the AC side of it. I'll let the capacitors bleed off there on the end. So yeah, we'll check out the frequency counter next. Okay, so now we're going to check the frequency counter on the multimeter I have here. And the easiest way to do that is actually to use my oscilloscope, because my oscilloscope's calibration point here has a constant standard that I can use, or a reference that I can use, in that the signal generated from the test point is 0.5 volts peak to peak at 1 kilohertz. So that would mean that if I were to take the alligator clips, or to hook the signal generator portion of this multimeter over to my oscilloscope's test points, I should read 1 kilohertz on the display. So let me put this into kilohertz mode. and set a range there. Now I've noticed that it just kind of has whatever crazy numbers it wants until I actually attach something to it, and even then it might take a couple of seconds for it to settle out and actually show me what the frequency is. Again, it's from 1971, so it's not the fastest thing on the planet, but it does do the job. So again, I've got my I've got the actual probe here on the oscilloscope connected up to the test calibration point. I'm going to disconnect that. Just like that, and I'm going to set this probe off over here. Now I'm going to get these connections from off of the signal generator or the multimeter here, and I'm going to attach the ground to the oscilloscope's ground wire I've got connected up here, and then the other end will connect up to the test point, which I'm not sure if that can be seen. It's right here. So let me attach it right on there, and we'll wait for it to count down, and there we go. It says 0.98 right there. You can see it. Let me zoom in on that a little bit. There we go. 0.98. If I drop it down here, give it a second to figure out, boom, 1 kilohertz on the dot, exactly where it needs to be. .987 would appear to be the more accurate measure there, and that's the most accurate I can get. Again, the white lines up here along the top, I don't know if they show up on the camera or not, but those indicate what range settings are valid depending on which mode I'm in. And since I'm in the frequency counter mode or kilohertz mode here, I can only use the 10, 100, thousandths, and 10,000th spot. And then 10,000 will also show a 1. So there we go. That's my cool little California Instruments multimeter. It's actually listed as a model 8420, but again, I have found basically nothing on this. I haven't seen any eBay listings for anything like this, and certainly haven't found any documentation on the web. So if you have any information about it, I'd be happy to know more about it. I mean, obviously it's a fairly simple multimeter to use. It is huge and heavy. For size comparison, here's a Sega Genesis controller in front of it. So you can see it's a pretty big piece of test bench equipment. But yeah, it's one of my new favorite toys, my little Nixie tube multimeter, bench multimeter. Thanks for watching.